Okay, after first lecture of IoT, S.Y.CS, today we are going to see FPGA. So हमने previous lecture में देखा what is IoT, how IoT device connected with sensor and actuators, the work of IoT. Okay, फिर उसकी definition सब कुछ हमने previous lecture में देखा. Then Raspberry Pi controller. Now FPGA. A field programmable gate array is an integrated circuit designed to be configured by customer or designer after manufacturing. So, FGA programmable gate array. Okay, this is one of FPGAs. Then this latency. How long does it take to compute something? FPGA are good at this. Okay, how long it does it take to compute something? कुछ compute करने के लिए वो कितना long compute कर सकते हैं? FPGA are good at this. Okay, then connectivity. What input output can we connect and with which bandwidth? FPGA can directly be connected to input and can offer very high bandwidth. Then energy cost. How much effort does it cost to express the computational? The engineering cost is typically much higher than for instruction based architecture. So the advantages must really be worth it. Energy efficiency. How much energy does it cost to compute something? This is often listed as a large benefit of FPGA. Are better than CPUs or GPUs, really depend on the application. Let's discuss each this in more detail. So first, latency or low latency is what you need if you are programming the autopilot of chat fighter or high frequency algorithm trading engine. The time between an input and its response as short as possible. This is where FPGA are much better than CPUs or GPUs, which have to communicate via the CPU. With the FPGA, is feasible to get latency around or below 1 microsecond, whereas with a CPU, a latency smaller than 50 microsecond is already very good. Okay, then connectivity. On a FPGA, you can hook up any data source such as network interface or sensor directly to the pins of the chips. This is sharp contrast to GPU and CPU, where you have to connect your source via the standardized buses such as USB or PCI and depend on operating system to deliver the data to your application. A direct connection to the pin of the chip give very high bandwidth as well as low latency. The high bandwidth is needed, for example, in radio astronomy applications such as LFR and escape. In this application, there are a lot of specialization sensor in the field which generate enormous amount of data. The volume of data needs to be reduced before being sent off to make it more manageable. So this is the connectivity. Then energy cost. Before turning to the suitable issue of energy efficiency, let's discuss the main disadvantages of FPGAs. They are really much harder to program, configure than instruction-based architecture, that is CPU and GPU. Traditionally, these hardware circuits are described via hardware description language like SDL, such as VHDL, and software is a program via one of plethora of programming language such as Java and C and Python. From theoretical, both hardware and description language and programming language can be used to express any computation, but different in engine details is vast. A large part of difficulty of programming FPGA are the long completion time. Completion time is take long. For example, when using Intel OpenCL compiler, it takes somewhere between 4 and 12 hours. Okay, means when using Intel OpenCL compiler, it takes between 4 and 12 hours to compile a typical program. For the FPGA, this is due to the place and route phase. The custom circuit that we want need to be mapped to the FPGA resource, that we have the paths as short as possible. This is complex optimization problem which require significant computational intel, thus often so testing for correctness does not require this long stay, but determining and optimizing performance does require this overnight compile phase. Then energy efficiency. In their communication, Intel is always touch point energy efficiency as clear benefit of FPGAs. This situation is really not that clear cut, especially when it comes to floating point. But let us first consider situation where FPGA are clear, more energy efficient than CPU or GPU. Where FPGA shine in terms of energy efficiency is at logic and fixed competition of cryptocurrency such as Bitcoin. Then how much energy does it cost compute something? This is often listed as a large benefit of FPGA are better than CPU or GPU. Really depend on the application. Then types of FPGAs. There are three types of FPGA. Field programmable gate array are classified into three types based on application such as low-end FPGAs, mid-range FPGAs and high-end FPGAs. So low-end FPGAs. This type of FPGA are designed for low power consumption, low logic density, logic and low complexity per chip. Example of low-end FPGAs are Cyclone family from Ultra. Then mid-range FPGAs. This type of FPGAs are the optimum solution between the low end and high end. FPGAs and these are developed as balance between the performance and the cost. Example of mid-range. FPGAs are from Ultra 7 series, from Sling, from Micro Semi. Then high-end FPGAs. The mid-range FPGA is the type of our optimum solution, okay, between low and high end, okay. Then high-end FPGAs. This type of FPGAs are developed for logic and high performance. Example of high-end FPGAs are Statics family from Ultra, okay. Then application of FPGAs. FPGAs have gained rapid growth over the past decade because they are useful for wide range of application. FPGAs are used for wide range of application. मतलब wide range के application में this is useful. Specific application of an FPGA includes digital signal processing, bioinformatic device controller, software defined. Okay, this type of application is handled by useful for handling the wide range of application. The application also mentioned like include digital signal processing, bioinformatic device controller. Okay, then AMD. AMD Advanced Micro Device and accelerated processing unit is the world's second largest manufacturer. World fastest. AMD solution allow to interact with technology in your way. 4 output of 5th supercomputer of world. today use AMD technology. The AMD Accelerated Processing Unit is also called Fusion. It is 64-bit microprocessor. AMD designed to act like a CPU as well as graphic accelerator GPU on single chip. Some of the example of APU are Sony, PlayStation 4, Microsoft Xbox, and Intel CPUs with integrated HD graphics. They all use semi-custom third generation low power APUs. The AMD Accelerated Processing Unit, or it's used, the project took their internal iteration of the fusion concept to create product for release. Reason for dealing the project are some of technical difficulties of combining a CPU and GPU on the same die at 45 nanometer process are related to the role the CPU and GPU should be in the project. Okay, the first generation desktop and laptop APU named Lelon was announced on Jan 4, 2011 at the 2011 in Las Vegas. It contains K10 CPU cores. The second generation desktop and laptop APU code name was was the Trinity. It features will deliver CPU cores, will driver CPU cores, sorry, and then GPU cores on the micro architecture on March 12, 2013 for laptops, mobile, and on Jan 4, 2013 for desktop under the codename Richland. The second generation APU for low power device. Okay, use exact the same APU chip but ran at higher clock speed. Okay, then APU, the APU branded product, optimized platform, architecture integration and system integration. Then description of process. This is given here. A max CPU clock rate is a 1.10 gigahertz to 3.2. Then instruction set is given and core 1 and 2. Okay. Then after define CPU, GPU, and FPGA and APU. In exam, they will ask like a question will come like explain FPGA. So you have to mention the definition, what the role of disadvantages, types of FPGAs. Then this is the define CPU, GPU, and FPGA and APU. So let's see CPU. CPU is a general purpose processor. General purpose in the sense that it is designed to perform a number of operations, but the way these operations are performed may not be best for all applications. Graphic or video processing in one such example. Although a CPU can perform this product, which involve repeated additions, multiplication, which may be performed in parallel. The performance achieved is not good enough for modern application. About a decade years back, CPU referred to a large spectrum of computing chips developed by various companies to execute. The one Today, the description only includes Intel's process with AMD remaining as distance. Intel victory has been purely due to economic reason. It was the only company which managed to scale up fabrication technology. The other company who lost the processor market have has been using their technical excellence in power consumption to come up with embedded board alternatives such as Raspberry Pi. We have seen in first lecture the what is Raspberry Pi, or staying relevant in the mobile computing market. Okay, then GPU, graphic processing unit. It designed to accelerate certain of image for computer display. These are designed to perform functions such as texture, mapping, image, rotation, translation, then an extra. They may also support operations such as motion, then calculation of inverse DCT for accelerated video decoding. The weakness of CPU architecture in parallel processing was apparent from the early days in display unit of computer because human eye is highly sensitive to any apparent in graphical rendering of information. Then FPGA. An FPGA field programmable gate array is, you can say, entirely different from CPU, GPU, DCP, extra in the sense that it is not processor in itself. It does not run a program stored in a program memory. In then FPGA is nothing but bulk of reconfigure digital logic suspend in C programmable interact connected. A typical FPGA may also have dedicated memory block, digital clock manager, I/O bank, and several other features which vary across different vendors and models. This makes them ideal for reconfigured computing and application specific processing. Okay, Intel has recently announced a new range of Hexon processor with integrated FPGA so that each chip can be configured at runtime depending upon application need. So it is very different from the CPU, GPU, and APU. Then about debates. Okay, FPGA technology from Ultra removes the fabrication problem by designing generic chips, customizable through hardware level programmable. Then FPGA contain gates and building blocks whose connections are reprogrammed by passing electronic signals into them. So after FPGA, let's see application processing unit. Application processing unit are abstraction that you decouple from your CPU to make CPU design simpler and faster, like SSC, MMX flags, which support vector computation. Okay, so here defined by it is, we have seen that CPU, GPU, FPGA, and APU. Okay, so what is FPGA? Is a field programmable gate array. Okay, then the disadvantages we have discussed in detail about latency. We can say low latency, then connectivity, engineering cost, what is the role, what is disadvantages. They will ask in exam. मैं आ सकता है आपको what is this like this question, what is FPGA and explain with disadvantages and types of FPGA. So this is the types of FPGA we have seen. Then accelerated processing unit. This is description of AMD. Then the difference, you can say the, if the question अगर exam में ऐसा आता है कि explain define the difference between CPU, GPU and FPGA. So you know that FPGA is entirely different than CPU, GPU and APU. तो सबसे अलग है. And what the role of FPGA you have seen. GPU we have seen already GPU in detail previous lecture. तो हमने पहले के लेक्चर में जीपीयू की डिटेल देखी है. देन इंक्लूडिंग एसओसी में भी हमें सीपीयू का क्या रोल है वो भी वी हैव सीन ऑलरेडी. ओके, एंड एपीयू नाउ हमने डिस्कस किया एपीयू के बारे में. ओके, नाउ इन नेक्स्ट लेक्चर वी विल सी द एआरएम आर्ट. व्हाट इज द रोल ऑफ एआरएम इन आईओटी. सो आपको इस पे क्वेश्चन आ सकता है जैसे कि राइट शॉर्ट नोट या डिस्क्राइब द डिफरेंस बिटवीन एफपीजीए, जीपीयू एंड एपीयू. देन आपको इस पे क्वेश्चन आ सकता है जैसे कि डिस्क्राइब एपीयू विद हेल्प ऑफ या डिस्क्राइब एएमडी या एपीयू. सो यू हैव टू मेंशन दिस description and then you have to mention the description about AMD. यू हैव टू मेंशन द फर्स्ट जनरेशन में क्या हुआ था, सेकेंड जनरेशन, थर्ड जनरेशन, कौन कौन सी मतलब यू हैव टू जस्ट मेंशन द जनरेशन एंड वो कितने माइक्रो प्रोसेसर का, मतलब इट इज अ 64 माइक्रो प्रोसेसर, एएमडी कितने माइक्रो प्रोसेसर का है, 64, देन इट्स एक्ट्स लाइक अ सीपीयू, सीपीयू जैसा वर्क करता है, एक्ट लाइक एज वेल एज ग्राफिक मतलब जीपीयू, एएमडी ये सीपीयू और जीपीयू के जैसे वर्क करता है, एक्ट लाइक द सीपीयू एंड जीपीयू यू हैव टू मेंशन। देन फिर आपको बोलना है सम ऑफ एग्जांपल, मतलब एपीयू के सोनी प्ले स्टेशन 4, देन माइक्रोसॉफ्ट एक्सबॉक्स एंड इंटेल सीपीयू विद इंटीग्रल एचडी ग्राफिक्स, these are the example। मतलब आपको एग्जाम में दे विल आस्क दैट, एग्जाम में अगर आता है डिस्क्राइब एपीयू, देन आपको एएमडी ये किसकी जैसे वर्क करता है, एएमडी कितने माइक्रो बीट का माइक्रो प्रोसेसर है, 64 का, देन ये एक्ट एज अ सीपीयू जीपीयू। ओके, देन इसके एग्जांपल क्या आपको मैंने कहा, सोनी प्ले स्टेशन, ठीक है। फिर आपको उसमें जनरेशन मेंशन करना है, फर्स्ट टू थर्ड जनरेशन इज देयर, फर्स्ट जनरेशन कब डेवलप, मतलब फर्स्ट जनरेशन कौन सी थी, 2006, देन उसमें कौन से मीन्स ऑलरेडी मैंने जो डिस्कस किया आपको फर्स्ट टू थर्ड जनरेशन, वो आपको मेंशन करना है, देन ओके। Okay, so okay, thank you.